everyone, welcome back to my YouTube channel. I am Kirti from Sri Venkateshwara College of Engineering. Presently I am pursuing my 5th semester of CSE Data Science. Today I am going to give a presentation on the topic of finite automata to regular expression conversion, which is a part of Theory of Computation course. Finite automata to regular expression. In this presentation, we'll explore about the conversion of finite automata to regular expression. It will cover the fundamental concept of finite automata and the process of converting them into regular expression and the practical application of this conversion. Introduction to finite automata. Definition. A finite automata is a mathematical model of computation that accepts or rejects the strings of symbols based on the finite set of states and transitions. It consists of a finite set of states and a starting state, a set of accepting state and a set of transition rules. Types of finite automata. The finite automata are classified into two types: deterministic finite automata, which is known as DFA, and non-deterministic finite automata, which is known as NFA. DFA as a unique transition for each input symbol in each state, while NFS can have multiple transitions from a single state. Finite automata representation. The finite automata should be represented using a state diagram and transition table. A state diagram is a graphical representation of finite automaton where states are represented as circles and transitions are represented as directed edges labeled with the input symbols. Transition table. A transition table is a tabular representation of finite automaton where the rows correspond to states, columns correspond to the input symbols, and the entire representation is next state. So here we can see the representation of finite automata. Transition diagram and transition table. State diagram can visually demonstrate the flow of computation through automaton, providing an intuitive understanding of its behavior, while transition table offers a more structured, compact representation of the finite automaton, facilitating the analysis and the conversion to regular expression. Formal definition of the finite automata. A formal definition captures states, input, alphabet, transition, start state and accepting state. It captures the key components of the finite automaton, providing precise mathematical framework for the analysis and the conversion. Conversion of finite automata to regular expression. There are two ways of converting a finite automata into regular expression. Those are state elimination method as well as regular expression construction method. State elimination systematically eliminates the state from the finite automaton, simplifying the structure and generating the intermediate regular expressions. The regular expression construction. The regular expression construction is a step of converting a finite automata to regular expression. It captures the behavior of the remaining states and transitions, representing the language accepted by the automaton. Algorithm for conversion of finite automata to regular expression. There are two elimination algorithms, which are state elimination algorithm as well as regular expression construction algorithm. This algorithm is typically eliminates the state from the finite automaton, progressively building a regular expression that represents the remaining states. When we have three states, we should eliminate the intermediate state first. After that, we can go for the final state and the initial state. While we are reaching the initial state from the beginning or final state, when it is reachable from the initial state, the final state should not be eliminated. This is the rule in the state elimination method. When we doing or performing the state elimination method, firstly we have to concentrate on the intermediate state only. After that we will get some expression which will be the regular expression of the finite automaton conversion. Regular expression construction. A regular expression is built based on the transitions between the states utilizing the operators like concatenation, union or nil closure to represent the accepted languages. So, in the figure we can see the conversion of the finite automaton to the regular expression, which is the algorithm of state elimination method. So, let us see some simple example and illustration. A simple example. A finite automaton by recognizing strings with an even number A's and can be converted to a regular expression through the state elimination method and expression constructions. Complex example. More complex finite automata recognizing the languages with specific patterns and conditions can also be converted to regular expression using similar algorithms. Practical application of the conversion. We are using the practical application of the finite automaton to regular expression conversion in our real life. Those are text search, network protocols and compilers. Text search. The regular expressions were widely used in text search engines to identify the specific patterns and strings within the large data sets. We can also take the examples of the string or pattern matching algorithm, which will useful for finding a particular pattern in a given string. Network protocols. A regular expression are employed in network protocols to validate the data formats and ensure the correct communication between the systems. When it comes to network, the correction or the perfection of the data is very important for validating that data format and ensure the correct communication. If any one bit of data is interrupted means the whole network will be interrupted with its communication. That's why the practical application of conversion of finite automata to regular expression is used in network protocols as well as compilers. Regular expressions are the fundamental to compiler construction used to recognize the keywords, operator and other language constructions. So, let us come to conclusion and the key takeaways. Finite automata is a mathematical model for computation with a finite states of transition, and regular expressions are the compact representation of the pattern and the languages often used in the text processing and computer science. The conversion algorithms exist to convert the finite automata to regular expression, enabling their application in various domains. By saying this, I would like to end up my video. Thank you one and all for watching my video. Please do like, share and subscribe.